Welcome back. Today we are going to continue graphing quadratic functions that are in vertex form. This first question is a review from yesterday's material. We are looking at transformations, and we have several in this one. Our negative in the front here is going to cause a reflection over the x-axis. That means instead of my parabola opening up, it's going to be upside down. The 3 that we see here is going to cause it to do a vertical stretch. So that means it's going to get skinnier. And then the 2 that we have here is going to move it to the right 2. And our last transformation, the plus 6, means we're going to go up 6. So we have several things happening here. To make this a little easier, we're going to start with our parent function, y equals x squared. We choose some values, typically negative 2 to 2, and we plug those into our equation, y equals x squared. So we're squaring each of these x values to get our y column here. Now, because we have 4 different transformations, we're going to look at the reflection and the stretch separate from the left, right, up, down kind of moves. So normally our parent function is here. We are going to flip this upside down. So now we're going to have points that are reflected over the x-axis. So the y-coordinates are going to change sign. Instead of being positive, they're going to be negative. So a reflection over x is going to turn all of these values for y into negatives. But then we are also doing a vertical stretch. So if we want to stretch them vertically by 3, that means my y value gets multiplied by 3. So my negative 4 now becomes negative 12. My negative 1 becomes negative 3. 0 times anything is 0. And we're getting the same values for those two. So if I plot those red points, so I'm using these x's and these y's, that means 0, 0 stayed the same. My negative 1 x coordinate is paired with a negative 3. So negative 1, negative 3. So this point right here that was at negative 1 got tripled, and now it's at negative 3. Same with this point. And then my negative 4s are going to turn into negative 12s. So you can see that my graph is much skinnier than the parent function. And then the last thing that we have to do is we have to shift it right 2 and up 6. So we're going to take this red graph and we're going to take all of our points and move them right 2 and up 6. So my vertex is going to move to 2, 6. Make that a larger dot. And then each of the red dots will move right 2 and up 6. All right, so I moved that one. Let's move this one right 2 and up 6. This one's going to go right 2 and up 6. And same with this one, right 2 and up 6. All right, so my new graph has a vertex up here, and so it's that same skinny parabola, it's just been moved up and to the right. All right, my axis of symmetry goes right through the vertex. So in this case, I would have x equals 2. Because it's turned upside down, I have a maximum point. My maximum right now is up here at 6. And notice that all of my y values are underneath that. My parabola is going down from there. So my range will be that y has to be less than or equal to 6. And if you remember from yesterday, we said domain is always all real numbers. All right, so just a quick review from yesterday. Graphing parabolas in vertex form. We're going to see if we can come up with some of this information without actually having to graph it. We're just going to visualize it. So identifying the pieces of a parabola without graphing. The first step is to identify the transformations. And then we're going to use those shifts to figure out our vertex. So in my example here, I have a 4 in front. That's going to be a vertical stretch of 4. And then I've shifted it to the left 1 and down 3. So if you can picture taking your parabola from the origin and stretching it, the vertex being at the origin, stretching 0 is still 0. But I am going to move it left 1 and down 3. So my vertex now is easy to find. I've moved it left 1, so my x-coordinate is -1, and I've moved down 3, so my y-coordinate would be -3. The axis of symmetry, remember, is a vertical line through the x value of my vertex. So if x here is -1, my equation would just be x equals -1. To determine if the parabola opens up or down, we had to look at our a value. In this case, our a was a positive 4. So since it's positive, we are going to have it opening up. And we did sketch a very quick picture. My vertex went, left 1 and down 3. So my vertex was here, and we said it's going to open up. So from that, I can determine max and min, I can determine domain and range, all of those pieces. So it's a max if it's at the top of a parabola. It's a minimum if it's at the bottom. Since ours is at the bottom here, we have a minimum. And the min or max value is just the y value of our vertex. And we said our vertex was at -1, -3. So I would say I have a minimum of y equaling -3. The domain of a parabola is always all real numbers, so even without graphing we know that. And the range of the parabola is based on the vertex and if the graph goes up or down from that point. So my vertex has a y-coordinate of -3, and all of my y values go up from there. So my range would be that y has to be greater than or equal to -3. So we can find a whole bunch of information without actually plotting the whole parabola. All right, so I'm going to have you pause the video and try these, see what you can figure out without doing a formal graph, and then turn the video back on and check your work. All right, let's check. So my transformations, the negative causes a reflection over x. The 2 caused a vertical stretch of 2. Our 3 here moved it right 3, and our 7 moved it up 7. So my vertex is going from the origin right 3 and up 7. So right away I can put coordinates for my vertex down of 3, 7. Remember, the axis of symmetry goes right through that vertex, so it would have equation x equals 3 to match the 3 I have here. We said our parabola had a reflection over x, so it is going to turn down from there. So we have a maximum, and the highest my y value gets is this 7. My domain is always all reals, and my range is based on that vertex. It's going to have a 7 for a value, and I just have to decide, am I going up from the 7 or down? In this case, the 7 here is my highest value. All of my other y values are going lower. So I would put in here that y has to be less than or equal to 7. All right, our next example. Again, there is a reflection. We don't have any kind of stretch or compression on this one, but we are moving it left 4 and then up 5. So my vertex is going to shift left 4 and up 5. My coordinates then would be -4, +5. Your axis of symmetry is always going to match your x coordinate, so x equals -4. Your min and max is going to come from your y value of the vertex, so y equals 5. And then we just have to determine if it's going up or down from that. Because of this reflection over x, we know that our graph turns down, so this would be a maximum point. Domain is always all reals, and the range again is tied to that 5, and since our y values are going down, we want to be less than or equal to 5. All right. We have one more question. This one is talking about writing a quadratic function in vertex form. It says the picture shows the jump of a dolphin. What quadratic function models the path of the dolphin's jump? The dolphin had a height of 7 feet after 3 seconds. So that's this point. And if you look at the graph, that appears to be the vertex. It's my highest value. So I know that I have a vertex at the point 3, 7. So when we think about our transformation, that's our generic transformation for a parabola. We already know which way we shifted it. We went right 3 and up 7. So right away, we can plug those values in. Right 3, up 7. Now the only other thing that we have to figure out is our A value. Did we stretch or compress this? It appears like we have flattened it out a little bit. So what we are going to do is we're going to pick another point on our graph, and you can see a dot right here, has coordinates 9, 4. We're going to use that point because when x is 9, our y value has to be a 4, since our graph goes through that point. So what we're going to do is we're going to put a 9 in for x and a 4 in for y, and we can work backwards to figure out what that A value should be. All right, simplifying. 9 minus 3 is 6. 6 squared is 36. All right, I'm going to subtract the 7 to the other side. So we have -3 equals basically 36 times A, 36A. And then I'm going to divide out the 36. So my A value is -1/12. Now let's think about if that makes sense. We should be getting an A value that's negative because our parabola opens down. Okay, so that's logical. And then the 1/12, because it's less than 1, is going to cause a compression. We've flattened it out. And this definitely looks flatter than a standard parent function parabola. All right, so then our last step is just to plug those values in. Y equals my A value of -1/12. We said we are moving to the right 3 and up 7. And notice that I have a square here. That's what gives you the parabola shape. So that's needed in my equation. All right, so you guys are going to practice these things on your worksheet.